Single-wall carbon nanotubes can be idealized as cutouts from a two-dimensional hexagonal lattice of carbon atoms rolled up along one of the provided lattice vectors of the hexagonal lattice to form a hollow cylinder. Carbon nanotubes can exhibit remarkable electrical conductivity, while others are semiconductors. They also have exceptional tensile strength and thermal conductivity because of their nanostructure and strength of the bonds between carbon atoms. One property of nanotubes is that they are really strong. Tensile strength is a measure of the amount of force an object can withstand without tearing apart. The tensile strength of carbon nanotubes is approximately 100 times greater than that of steel of the same diameter. There are two things that account for this strength. The first is the interlocking carbon-to-carbon covalent bonds. The second is the fact that each carbon nanotube is one large molecule. This means it doesn't have the weak spots found in other materials, such as the boundaries between the crystalline grains that form steel.
A special group of aqueous single-wall carbon nanotubes are metallic, but all the rest are either small or moderate bandgap semiconductor. These electrical properties, however, do not depend on whether the hexagonal lattice is rolled from its back to front or from its front to back, and hence are the same for the tube and its mirror image. Multi-wall carbon nanotubes consisting of nested single-wall carbon nanotubes weakly bounded together by van der Waals interaction in a three-ring-like structure. Carbon nanotube can also refer to tubes with an undetermined carbon wall structure and diameters less than 100 nanometers.
At first, in this study, we will go through the application for the lattice or Faridah lattice in physics. Lattice we set as a regular periodic configuration of points, particles, or objects throughout an area of space, especially the arrangement of ions or molecules in crystalline solid. So, from our observation in Pusat Sains Negara, we can see the application of lattice for crystalline solid at the dome of building. They have an interesting pattern or lattice. At first, we know that a fundamental concept in description of crystalline solid is that of a Faridah lattice. A Faridah lattice is an infinite arrangement of points in space that has the following property, which are the lattice look exactly the same when viewed from any lattice point. We can see in this identity in this dome of building. We can also see in 1D Faridah lattice, 2D Faridah lattice, and 3D Faridah lattice.
Next, we move to the Wonder Spark Gallery. There are a lot of exhibitions here that relate to the natural phenomena involving light, wind, land, and aqua. But we were interested in this cube of glass full of colorful lights around it, where people can stand above it. Glass is an example of amorphous solid because its atoms are not organized in a definite lattice pattern. Glass is made by cooling a mixture of materials in such a way it doesn't crystallize. Glass doesn't have a sharp melting point but melts over a range of temperature. When the glass is heated, it slowly softens and can be shaped into all sorts of interesting forms. Since the glass is non-crystalline, the amorphous structure makes them inherently strong but invariably brittle depending on its thickness. When the glass shatters, it will break in an irregular way.
I didn't get the chance to go to the National Science Center with my friends because I was sick. But from the video that they took and the story that they told me about what happened that day, I can say the experience they had that day is great. I wish I could be there with them to experience it together. There are so many things that we can relate with what we have learned in solid state.
Hi and Assalamualaikum. I am going to share my reflection towards this task. Even though I didn't get to join this field trip, but through my observation through my group members video, I can see that this field trip was fun. It is because National Science Center serves us with fun and interactive gallery that applies the concept of playing and discovering while learning in an interactive, hands-on, comfortable and exciting environment. It is very interesting and plus at the same time we can discover lots of things there where everything are related to science. We can get more knowledge there and last but not least I hope I can experience it too with my group members.